All right, welcome back. In our previous video, as part of this skill for static routes in IPv6, we had a little strategy meeting on how to implement static routes. And what I would love us to do, if you're okay with it, is having default routes on R1 and R3, and then having two network static routes on R2 to reach the 1 and 3 networks, or maybe that's 1 and 3 networks, respectively. So let's take a look at the topology to make sure that we are clear on the routes that we're going to add, and then we'll go right into the hands-on lab. And I would encourage you to practice this alongside with me, either using the virtual labs that we provide or using some other emulator or simulator or live gear or packet tracer. But the secret is do the practice, get the hands-on practice, and that way we can improve those skills every single time that we practice. And that makes us more valuable in working with, troubleshooting, and verifying network connectivity. So let's take a look at our topology. So here it is from our last discussion, and we are going to do a default route on R1 that says you need to reach something not local, use R2. We're going to create a default route on R3 that says you need to reach something IPv6 wise not local, use R2. And we are going to create two static routes on R2, one for the 1 network and one for the 3 network. And with that plan in place, let's go to DCNUG, our administration machine, and let's open up PuTTY, and let's get to work configuring R1, R2, and R3. All right, let's start by opening up the topology so we can look at it at a moment's notice. There's our topology. And let's open up connections to R1 and R2 and R3. Fantastic. All right, so let's start off at R1. Our plan for R1, if I look at my notes real quick. So here on R1, we're going to create a default IPv6 route that says to reach anything outside of what you know about already, go ahead and forward it to the IPv6 address of R2. So let's go ahead and make that change. So let's do it. Let's go to configuration mode, and we'll do an IPv6 route. And the syntax for the default route is : /0 space, and then the next hop, which is going to be 2001 :db8 :6783 :12 :2. And if we wanted to, this is also how we could add on an administrative distance greater than 1. So we could have floating static routes and floating default routes in the world of IPv6 as well. I'm going to take the default and press enter, and boom, we've got our default route. If we do a end and a show IPv6 route, press enter, and now we have, in addition to our other directly connected networks, we have this static default route using the good buddy, the good pal R2 at this IP address. Fantastic. All right, now there is one other thing that we need to do, and I want to do it here before we leave, and that is we have to tell this router that it should be willing to be an IPv6 router for other people's traffic. And to do that, we're going to go back into configuration mode. I just washed my hands and can't do a thing with them. We're going to go back into configuration mode and use the command IPv6 unicast routing. Enter. If we don't enable IPv6 unicast routing, we can have routes all day long, and the routers won't route for other people's traffic. So we want to include that also on each of the routers as we go through the config. All right, let's do a show IPv6 interface brief. And let's also do a show IPv6 interface. There's a lot of output coming up here, but it's all good stuff. So there's our global address on gig 00. There's the network that we're attached to. Here is the link local address, FE80::1. It's also joined some multicast groups that are used as part of the functionality for IPv6, including being a router. All right, I'm going to hit Q for quit. Let's go over to R2 and configure the two static routes there. And if we look at our topology again, on R2, we're going to create a static route for network 1 using R1 as the next hop, and for network 3 using R3 as the next hop. So here we go. We'll go into configuration mode. I'm going to do the IPv6 unicast routing so I don't forget it. And then let's configure the static routes. So IPv6 route, and the first one is 2001 :db8 :6783 :1. That's the network over on the left-hand side of our topology, : and then a /64 space, and then we're going to put in the next hop, which is going to be 2001 :db8 :6783 :12 : 1. And if we want to modify the administrative distance, we can. The default's going to be 1. That'll work, and we'll press enter. The other thing I'm going to do is I'm going to copy this just by clicking and dragging over it, so I can just right click and paste that and not have to retype it every time I want that portion of the IPv6 network. So I'm going to hit the up arrow key, and we'll change this one to be, instead of trying to get to the 1 network, we'll specify this is the 3 network, and the next hop is going to be :23::3 for router 3's next hop address. All right, those look good. So we'll verify that, show IPv6 route, and I'm going to throw in the static option there as well. Okay, so we have 2 routes, one for the 1 network using R1 as the next hop, and one for the 3 network using R3 as the next hop. That looks pretty good. And we did the IPv6 unicast routing. That's good. So we'll go to router 3 and we'll complete it here. So on router 3, we're going to do a default route here, IPv6. I'll add the unicast routing to begin with, and then we'll add the default route, IPv6 route to : /0 space, and the next hop is going to be R2, which is right click. Hold on a second, let me go copy that. I'm going to go copy this right here. Copied, and back to R3, hit the up arrow key, and right click. There we go. All right, that's what I intended to happen the first time. And the next hop is going to be, from R3's perspective, it's going to be 23::2, which is R2, and that is all we need. So if we do a show IPv6 route, and I'll just look at the static routes for a moment. And there it is, 2001 DB8 6783 23:2 is the next hop for that default route. Now, how do we test this? Ooh, this is getting fun. So to test this, we could involve these guys. We can involve the server and the PC. But when we're building networks, if we can verify our connectivity from this network 1 to network 3 without the devices involved, that just removes one layer of challenge or problem. If their default gateway is not set up, or they're not properly set up for IPv6. So what we could do is we could, if we started here at R1, we could do a ping to this network. So 2001 DB8 6783 3, and then some device that's at that network, which would be : 3. So if we ping that, that would verify connectivity from the 12 network over to the 3 network. Or we could source some traffic over here from gig 00, and then the reply would have to go back to the 1 network over here, and that would verify end-to-end connectivity, which is a better test. So let's do that. Let's go over here on R1 and take a look at how we can test full connectivity from the 1 network with IPv6 over to the 3 network with IPv6. And while I'm here, I'm just going to use the mouse and drag across this number, which I'm going to paste in to save us some typing again. So going back to R1, let's do a ping, and we'll do a right mouse click to paste 6783 3 : 3, and hold our breaths. You know, that doesn't always happen the first time, especially with IPv6 with all the addresses going on. How could we prove? Oh, let's source it. Let's do a source from our IPv6 address on gig 00. So we'll source it, and I'm going to paste again 6783 1 : 1. So that'll source it from the 1 network on R1, and it'll send it over to R3's interface over on network 3. Wow, okay, that's cool. Now, how do we verify it's really going through the path that we think it is? And one great tool is traceroute. So traceroute, it also is very flexible. It can work both with IPv4 and IPv6. So if we did a traceroute over to this destination right here, I'm going to paste that in. That'll show us the path. Sure enough, so from R1's perspective, it went to R2, and then from R2, it went to R3, who then responded back to us. So if we wanted to ping like R2's 1/0 interface, which is 23::2, and press enter, that should work as well. And you know what? Working with a plan as far as how we're going to implement our routing with static routes with IPv6, and then implementing it and verifying it, including looking at the routes, is fantastic fun. Also, because there are more characters involved, sometimes there's a typo or two, and that gives us the opportunity in a lab environment to say, wow, it didn't work. Why didn't it work? As we go back through, look at the routes, look at the IP addresses with show IPv6 interface brief, show IPv6 route, just to help verify where it went wrong in the path. Or maybe we just failed to implement the IPv6 unicast routing command and the routers were not willing to forward the traffic. So the actual practice here is going to lead to additional practice in troubleshooting. And so if you want to walk through step by step with this video, I would encourage you to do it maybe once or twice. Make sure you've got it down. The more you practice with whatever it is, IPv4, IPv6, static routes, dynamic routing, the better you'll get, the more familiar you'll be with the product and how it works. And that means when you're in the production environment and there's a problem, you'll know what you can look at or how to look at it and how to better address it to support the company. And that's a valuable set of skills to have. So thanks for joining me in this hands-on lab for static IPv6 routes, both default and also network-based, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.